This is the 5th video presentation for the CASE Food Science and Safety course. As you view the video, please be sure to make notes of important information. Feel free to pause, repeat, and resume the video whenever necessary. Food Preservation, Lesson 4.2, Processing for Preservation. You just completed Part 1 of Activity 4.2.1 Pasteurization. To equip you for Parts 2 and 3, this presentation provides information about preservation. Moisture removal, thermoprocessing, acidity adjustments, and non-thermal processes are all used to preserve foods. Water activity is the measure of available water in a food product. Food scientists measure water activity with hygrometers. When you remove free water from a food, growth of spoilage microorganisms is inhibited or eliminated. Enzymatic activity responsible for spoilage is slowed or stopped. Pure water has a water activity reading of 1.00. Most microbes stop growing when water activity is between 0.70 and 0.85. That doesn't mean the microbes die, they just become dormant. When the water activity returns to viable levels, microbes regain life processes and flourish again. The main function of dehydration is protection from spoilage. There are other benefits to consumers, such as food is lighter weight and takes up less space, which reduces shipping and storage expenses. Dehydrated food also saves time in the kitchen by providing the taste and texture of fresh food products more quickly than traditional cooking. Some foods are used in their dry state, such as raisins and prunes, while others are designed to be reconstituted. Reconstitution refers to the process by which water is added to the dried product to return the food to its prior state. Benefits of concentrates include that they are more economical to ship, they have a longer shelf life, and they are used in the industry as a step to simplify handling for other processes such as dehydration. Problems with concentrates include quality changes such as cooked flavors or color changes. Concentrated foods often have a sugar crystal formation, denatured proteins, and a higher risk of foodborne illnesses. Heat treatment and cooling or freezing slow the growth of microbes and denature enzymes that cause food spoilage. As soon as foods return to viable temperatures for microbial growth and enzymatic activity, the rate of spoilage processes will increase. Blanching is used as a process to prepare food for further processing. Blanching is the process where food is boiled or steamed for a short period to denature enzymes. Pasteurization is a low heat treatment that slows the growth of pathogenic microorganisms and halts enzyme activity. Canning food destroys microbes, so there is no growth of microbes in the canned environment. Sterilization kills all microorganisms using wet heat. Sterilization is intense and would make most foods inedible, so it is limited to foods that are in pureed or liquid form. Conduction is used when the food is packed solidly in a container. Conduction is the transfer of heat between adjacent solid materials. Convection is mainly used for liquids. Convection is the transfer of heat through a medium like water or air. The cold point of a food is the last point to reach desired temperature, usually somewhere in the middle. In conduction, the cold point is in the center of the can. In convection, the cold point is below the center point because the colder, denser liquid will sink toward the bottom. A thermal death curve is a line plotted on a graph telling food scientists what length of time a certain food must be cooked at a given temperature to kill a specific microbe. The components of the food influence what is the best method of processing. The pH determines the types of microorganisms that are common for specific food products. Microorganisms that inhabit low-acid foods with a high pH can kill a person. They must be processed at temperatures significant enough to kill the microorganisms. The ingredients affect the safety of the microbes and the transfer of heat energy. Refrigeration changes the quality of food the least. but does not extend the shelf life as long as freezing. Freezing increases the storage period for many foods. Instead of a few days, freezing adds weeks and sometimes months. Manipulating pH raises or lowers the pH in order to denature or inactivate enzymes. New and improved processing technologies also extend the shelf life and quality of foods. When food is irradiated, it is exposed to radiant energy, causing chemical changes in the molecules, resulting in death of a large percentage of microbes and slowing the growth of others. Irradiation increases free radicals, which already exist in the food product. Packaging must protect food from damage, dispense food as required, protect food from outside factors, and identify the product. Packaging must do all the previous mentioned things without affecting the food product. Biotechnology is manipulating plants and animals to change and/or improve them. Biotechnology raises concerns with consumers as well. For instance, scientists developed a tomato that could withstand colder temperatures by adding an anti-freezing gene from a flounder. An interesting question arose: can these tomatoes be included in a vegetarian diet? What are your thoughts? As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. And keep any notes you have from this presentation organized and available for use throughout the course. Through Activity 4.2.1, Pasteurization Preservation, you will evaluate microbial growth of 2 buttermilk samples in order to understand how heat treatment is used to preserve food.